Okay. Okay. Yes.
Hello, everyone. I am very pleased to present today an old friend and amazing researcher, Dr. Baptiste Caramiaux, who is currently a CNRS researcher who also has his HCR already at the Institute of Intelligent Systems and Robotics at Sorbonne Université in Paris. So this is ISIR, where also Thomas is being co-directed for his PhD. So his work looks at the intersection of human-computer interaction and machine learning. And previously, Baptiste was at IRCAM for his PhD and was also at Goldsmiths and at McGill University working with Marcelo Wonderly, who is a pioneer in music interaction, also with Atao Tanaka at Goldsmiths. And these days, Baptiste is working on problems at the intersection of machine-assisted, ML-assisted human learning, interactions with machine learning, AI, and artists and culture, as well as human-AI trust, and the intersection of AI with politics and cultural practices. So please give a warm welcome to Baptiste Caramiaux.
Thank you very much. So yeah, thank you for the invitation. There's a strange kind of delay, but that's fine. Yeah, so as you mentioned, I am a HCI researcher at ISIR, and today what I wanted to present to you today is maybe one part of the work that I'm conducting with colleagues and students about considering machine learning techniques as design material. So the idea is a bit to explore that idea and maybe to discuss that idea with you after the talk. So to start with, maybe you have seen the video because I was just tested the sound on this video before, but I wanted to show you this artwork by Memo Akten. Maybe some of you know this artist. But let's have a look at this piece. The idea of the piece here is basically Memo capturing his image from a webcam. And what you can see as output is a generative neural network generating the image in real time and learning how to generate the image in real time. So if basically the artist is, Memo is kind of still and doesn't move, the system managed to recreate the image. As soon as he starts to the system has to recreate, learns how to recreate a still image. And what I found really interesting in this work, so this is more a demo for him, is basically as an artist working with AI or machine learning, what he was actually doing is like, okay, but for me to work, I have to expose to myself the learning process of the model. And that way, I could understand what the model learns and how I can steer the model towards what I think it's interesting and aesthetically interesting for him. And eventually, it became an artwork about surveillance and exhibited in a museum. But what I found interesting here is that basically, since the learning process is exposed, what we can see is that in a way, it becomes kind of a material. Here you can see a bit the materiality of the generation that the artist is playing with. So that's an illustration of what I'm going to talk about in this presentation, basically. Just a quick reminder of machine learning, and not as I mean, I don't want to do a course on machine learning because that's not the purpose, and I guess most of you know what it is, but I felt it was important maybe just to remind a few things that would be useful for my talk. First, what is the kind of new thing with machine learning techniques compared maybe with the previous way of programming machines? So that's what it's represented here. So basically what you can see on the left is maybe what you do with programming, like classical programming, let's say, where you have some inputs, you write a program, you do the computation, and you have the output. So it's what we call deductive machine or hypothetical deductive machines. Okay. What is very interesting and what is new with machine learning is this inductive nature, which means that instead of giving a program that you wrote, you can give the inputs and the outputs that would kind of represent the type of behavior or the type of program that you would like, and the system will generate the program that will, from this input, will generate this output. So inputs can be an image, and output can be the same image, and you want the machine to be able to recreate the image that you give as input, for instance. And so this inductive power is really interesting because that's where you can really conceive the way of designing machines and interaction, not from programming and not from like hypotheses that you will have about the behavior of the machine, but with examples and demonstrations. Interestingly, in 2012, as you might know, so now more than 10 years ago, there has been this deep learning breakthrough, which is basically a family of machine learning techniques that allowed really to tackle real-world problems, so such as image classification, image generation, sound generation, detection, and all these things. This was 2012, and basically what this technology is made of what we call neural networks. That is a kind of a complex model that has several millions of parameters. And why I'm talking about this breakthrough here, because it's not a talk about machine learning, and that's not the purpose, but because what I'm interested in is how it has been conceived, how it has been perceived, this breakthrough in the machine learning community. And this is a quote from an AI and machine learning researcher that has been reported by Dominique Cardo and colleagues in this article. So I'm going to read it. He's talking about the moments where they presented the result at this conference in 2012. So they said, like, the thing they did was to remove all the feature extraction and take the raw image. So the task was image classification. The guys who did that with Hinton, so the head of the team, are crazy because it's one thing to reproduce, but to go like that and explore. They made system of a complexity that we didn't imagine, and they were able to make them work. You take a paper from these people, you look at it, I'm scared, I'm too old. The guys talk to you as if they were almost programming. They don't make a description of this equation that makes sense to me, but in 5 lines, they are going to describe a hyper-complex thing. So that means that he made an architecture in which he put 100 elements together, and for each one, you have 10 possible choices to link them. He played with them to make it work. It's a hacker job. And so that's, for me, illustrate also these new eras that deep learning brings as a way to not anymore maybe relying on hypothesis and equation in machine learning, but like more on craft, on materiality of the model that they are playing with, so layers, artificial neurons, activity function, and so on. And so even in the AI research, you have, or starting from AI research, you have this idea of designing material and crafting. Okay, so in my research, I tried to conceive the machine learning techniques and algorithm in 3 different ways. Sometimes as a tool in order to achieve a task, sometimes as a material for designing something that is useful for us, and namely in the artistic field or creative field, or sometimes as a cultural objects or political objects. So the goal of my talk today, okay, is actually to focus on the material aspect. And I think that the animation again, but if you are interested in maybe the other facet of that research, I put here, I wrote this in my habilitation en direction de recherche that I defended last year. So if you're interested, you can look at this manuscript. But in this talk, I will focus really on this idea of machine learning as a design material. And I will just remind where I come from in order to give you also my interest in this research topics. So as Xiao mentioned, I did my PhD at IRCAM, which is a music tech lab, and I was really much interested in gesture-based musical interaction design. So how you can transfer movement expressivity in sound, okay? With influence by these artists, Michel Weisswitz, Atao Tanaka, with who I work, or Leticia Sonami, who is a pioneer in this field. But basically what we were trying to do back then, so 2012 to 2015 or 2010 to 2015, is basically develop some machine learning algorithm, like namely gesture recognition system, in order to capture the gesture, to be able to link this gesture to sounds. Okay, so do you have a training phase where you give example of gesture that you would like to associate with sounds. The system learns the mapping, and then when it's trained, you can perform new gesture and you will perform the sounds. You will shape the sound as the way you personalize the model. I was not alone working on that. Obviously, you have a bunch of reference below of colleagues: Rebecca Fibric, Jules Françoise, Nick Gillian, Frédéric Bevilacqua. There are other researchers working in this field. We apply that to music, but we also apply that to rehabilitation and motor learning, so trying to recognize gesture and track the way gesture is performed. So this is just an image because we talked about this morning. This is the work by Veini Sangili. But in all this work, basically, we were really focusing on, okay, let's build gesture recognition as a tool to recognize gestures, basically, okay? So the task was that. And at some points, I started to collaborate with Marco Donnarumma, who is an artist, performer, on this piece, so it was 2015. Let me show you an excerpt of this piece, and then I'm gonna comment it. Okay, well, I think the sound was not really, we couldn't really hear, but that doesn't matter. You can look at this there is a lot of videos online. So in this piece, if you, in order to understand, so the artist has an EMG sensor and MMG sensor, mechanomyogram and electromyogram on the arms. And through this sensor, we are capturing the expressiveness of the movement and the tension that there is in the movement, or the configuration, the muscle activities that they are. And this signal is, or this quality that is extracted is actually controlling light and sound, okay? So initially when we started to work with Marco, it's like, okay, I'm working on gesture recognition or like a quality recognition. And he's working on performance, body-based performance. So let's work together in order to recognize his body expressiveness and use that in a piece, okay? And it's there that I really realized that considering machine learning as a tool hides a lot of the underlying materiality of the technology. Why? Because when we started to work, I had my algorithm, I plug it on these signals, and obviously it didn't work. So what happened is, like, we iterated, we changed the algorithm, and we started to understand what it means gesture expressiveness from the perspective of the artist, and what it means a gesture from the perspective of the algorithm. And all this created an iterative process where eventually what we developed was something completely different than what we had initially. But all the process that we went through was really source of knowledge. And we actually wrote a paper on how we understood gesture expressivity. And so I think implicitly we applied some research through design process in this work and so I adopted another epistemology that we had before when we were considering machine learning as a tool. Here, basically, the materiality of this technology help us to understand something about gestures and gesture expressiveness. And it's what I'm going to dig into. So if we consider digital materiality, what it is, so we can think about digital materiality as things that can be used to make artifacts in digital environments, right? What can be computer programs, data, algorithm, graphical interfaces. And in the field of human-computer interaction and design research, there has been several people working on that, trying to understand what is this notion of digital materiality. So you can read Valgarda, Redstrom, Sundstrom, Jaccardi, and so on. A lot of them are actually come from a Scandinavian philosophy and Scandinavian feminism, and they are working on this. We're working on this topic. I put here an image of Max MSP for those who know this program, because I feel that is also an interesting illustration of materiality, because Max MSP is a graphical programming environment where you can plug strings from one block to another, and some blocks are processing data, or they're processing audio signal, and you could see basically what happens. You have a graphical interface, and you have a visualization of when the signal is going through the different blocks, and this gives you some kind of visualization, or this gives you a materiality of what happens below, about signals, about control signals, audio signals, and processing. So if we imagine digital materiality transferred to machine learning, and reminding maybe what I started to talk about with Memo's work or with the collaboration with Marco, we can think about elements of materiality in machine learning as what? Like the data set used to train this model, the model itself and its parameters, the training process, how you want to expose that training process. For instance, Memo was exposing it visually, and so on and so forth. Can be also the metrics you are using, and so on. The thing is, also in HCI, in human-computer interaction field, I mean, I'm not the first one thinking about that, and actually other researchers try to say, okay, let's see what happens if designer, UX designer, UI designer are using these techniques as material. And it's actually very challenging. So there's these two papers now that are 6 years old, they conducted interviews, and they really highlighted why it's difficult to work with this technology. And there are many ways, many reasons. One of them is it's hard to understand what you can do with it before trying it. So another aspect of digital materiality is the expression of material. So when we are designer working with physical material, this idea of expression is kind of natural in a way. I mean, if I am a ceramist and I'm working with clays, the type of clay I'm going to use will have different expression when I'm firing it or not. So that's part of the expression. So what is this material expression in the digital world? That's not really clear. So Johan Redstrom, who is this designer, talk about this hidden material expression in digital technology. And again, I'm going to read the quote. He says, another reason for thinking further about the idea that the material expression of technology are hidden rather than non-existent is that early example of technology, particularly before devices are working perfectly, often have a very strong expression in themselves. So he gives an example of radio and television, where, for instance, the signal transmission and reception were expressed as noise. And that's very true when you are using an old analog radio. When you hear noise, it's an expression of a bad reception. Okay? And the same with television. And digital radio has other kind of expression when you actually have glitches, you know. And there is a kind of a tension between engineers that tends to correct the bugs and the glitches, and maybe designers and artists who are basing their work on these glitches, because this is an expression of the material they are using. So how you combine the two, how you can mitigate this tension, that's an open question. And so in machine learning, we have this example. So I put these pictures here. So if you know a bit of machine learning or deep learning, this is a GAN, so a generative adversarial network, or actually a different version of generative adversarial network from 2014, which is when the GAN has been published for the first time by Goodfellow et al., until 2018. And then it started, I mean, there is other extension. But just looking at this, you see the different version of the algorithm. And what happens is that, okay, it becomes more realistic. It can tackle high resolution image. So for an ML researcher point of view, or technical point of view, is that this is a progress. This is going forward. But like if I am a designer or if I'm an artist, maybe I will find more interesting the black and white first version of GANs with this very characteristic of this technology, of the expression of this technology. But that's again an open question. So where does lie the material expression of generative AI? So in my work and with colleagues, what we are trying to do is, or part of it is actually to go to see artists that are working with AI and creatives and trying to understand how we can study materiality through a better understanding of artistic practice with machine learning. And so the question we are asking is how artists involve AI in their work at the first place, and how can artist practice help us to rethink our interaction with artificial intelligence or machine learning, especially beyond the concept of a tool, okay? So I'm going to present just one aspect of this paper that we wrote with a colleague of mine, Sarah Abdilialawi, that has been published two years ago, where we interviewed 5 artists, some of them, 5 pioneer artists in AI art, the so-called AI art movement, who are these 5, Memo, Jake, Mario, Kyle, and Anna. We interview them, we kind of trying to understand what are the practice of machine learning and how they integrate machine learning in their work. I won't go through all the findings, and you can read the paper about the different practice and politics of that technology. What I want to focus on is a couple of examples. So here is an example of work by Anna Riedler, from 2018. So it's also using generative adversarial network. So we are pre-text-to-image generation tools here. But what is super interesting in her work is that, on the left, what you can see is more than 1,000 pictures of tulips that she took herself, and she labeled, annotated herself manually. And from this is the data set. And then she trained a GAN, or several GANs, in order to produce this video output that you can see on the right. So on the left is the input data set, on the right is the output of the model. And she's exhibiting the two aspects. And what is super interesting in her work is that the way she actually associated practice with craft. So she said, I actually think there are a lot of parallels between craft and art and between data and models. I think there are a couple of things like the relationship between craft, which is anonymous and less well regarded, its repetitive nature, and art. And when you see the dataset are anonymous and nobody talks about them. They are out there and people are using them. And that's true that for many years, in the AI and machine learning research, that the dataset were this kind of useful thing that are used by this researcher, but what is published or what is shown is more like the model that they managed to train. But behind the scene, building a dataset, that's really a craft work that is very important, obviously, and you might have seen all the problem with biases that we experienced in the last year since the beginning of deep learning, basically. And then it's fundamental for the working of the techniques. And so in her work, she's really putting forward, she's exhibiting this craft, this this crafting practice and exhibiting in a way the materiality of the technology that she's using. Another aspect of this technology linked to the digital materiality is from Mario Klingelman, and it's about uncertainty. Because working with this technology is not only working with data and with outputs, is also working with uncertainty. This technology, for most of them, they are stochastics, meaning that if you give the same input 2 times, you won't have the same outputs. Okay. But for some artists, this uncertainty is really meaning making. So you could work with uncertainty, you could design uncertainty in order to create something meaningful. Well, in the artwork, in this work, what he says, like, it reminds me of Francis Bacon. Well, that's true that he's super influenced by Francis Bacon. This is one of his pieces on the right. In fact, now I feel closer to him. There is this work with oil paint. He looks for accidents, so Francis Bacon. That's exactly the point. When you work with oil paint, it also has this certain behavior when everything mixes, and it's sometimes quite hard to control. So you can't deliberately push it in a certain direction. That's what he says. So in working with it, there comes a time when a certain constellation is right. Then you stop. And you also have to decide, is this the best solution or not? So should I work on it? And that's what I found. So that's what Marco finds, Mario. In my work, keep training and you may destroy it entirely. So he kind of make this parallel between working with like physical paint and all the uncertainty that you work with this material, and the same maybe you can transfer to ceramics. When you fire your ceramics, you have a lot of uncertainty of how it comes out. With this technology, where this uncertainty is also something that you have to work with, and is part of the materiality of your technology. And something that I found very interesting is like this notion of keep training or not. I mean, it's not a trivial question to say, okay, when I should stop training my model? When is good enough? So when you do machine learning research, you have some kind of metric saying, okay, if I reach this accuracy, it's good enough. And then when it drops, okay, I should stop here. But when you start to think about this in the design work, I mean, when is good enough? It really depends, and that's an open question. And it comes back to the fact of exposing the learning process in order to understand when it's good enough or not. So we transfer this idea of working with materiality to other fields. So this is a work that I've done with the postdoc of mine, Hugo Scourteau, who is also an artist, sound designer, researcher. We try to kind of work. I mean, the goal of this work was to build a generative model that will allow to generate respiratory waveforms, okay? Breathing waveforms. In order to build a soft robot, which is here, which is like a breathing, to be faced to patients in the hospital. So the main idea is like, if we manage to build a soft robot that is breathing in a kind of expressive way, we could help patients who are in respiratory distress to kind of calm down and distress. And what we did is basically in order to build this tool, this machine learning based tool, we follow the same type of work that this artist did, basically taking the data, trying to understand the data with the pneumologist, iterate on the model, always working with the people at the hospital, and trying to understand when our model was good enough. We did not have any metrics to say, okay, this is realistic as we want. What we did is more like we generate some kind of bunch of waveforms, and we are discussing with the pneumologist, and then we iterate it. And the pneumologist could actually annotate our waveform to say, oh, this is strange, this is abnormal, or this is really clear, and so on. And they didn't know if it was generated by a system, by a machine learning technique or not. So we mix both human and machine learning based. And we build also a kind of user interface to be able to explore for us first the latent space of these breathing waveforms. So in order to explore, the same way that you're going to explore an instrument, you're going to explore this in order to understand where you have that the quality of relaxed breathing, or maybe a quality of stressed breathing, for instance, because there is no guide that tells you where you should look at. So all of this is exploration of the materiality of data and the model in order to build this soft robot that is now, this year is going to be put in the hospital, and we're going to do the clinical study. 30 minutes. I'm going to just make a quick discussion or point about the fact of enabling materiality through interactivity. So in the work I've shown, you have seen that the way we interact with this technology is not much maybe the way that ML developer or AI developer are doing it, in the sense that we try to bring interactivity at the very front. So, and this is very much in line of this field of discipline of research in HCI, which is called interactive machine learning. So in interactive machine learning, what we try to do is really to open the black box. Is really to avoid that end user, or let's do it in another way, is like to involve the end user in the learning process. Okay, so the user, who are people usually novices in machine learning, could interact with the machine learning based model through data directly, so providing examples, feedback, selecting the model they would like, changing the parameters, so really exploring the capacity of the system. And as feedback, they get what? They get the prediction, they get for instance, generated images, they get some rewards, precision, recall, cluster, whatever, depends on the task. And what is interesting in this IML, interactive machine learning workflow, is that you avoid this distinction between development and usage. So everything is mixed. So the end user becomes the tester, but also the user and the developer. Okay, and it's exactly what happens with the the system I show with Memo, and also the system I quickly presented with the breathing waveforms. So we have a bunch of articles here, and if you are interested, you can look at. We build a tool in order to design more simply interactive machine learning techniques. So it's called Marcel, and this tool is basically what we use in most of our work. The case of the breathing waveforms behind is also Marcel, and we have a bunch of other projects that we are using this toolkit in order to build interactive machine learning application running in the web, or also in the mobile phone. It's a web app. So on the website you have a bunch of demos and so on. Okay. So the last element I would like to present is that as part of this interactive machine learning workflow that I presented, where the user becomes involved in the learning process, in the learning loop, there is another approach and formalism that we are pushing nowadays with some of my students and colleagues, is this idea of machine teaching. And it's kind of the same thing, it's just that what we try to focus on here is even more relying or leveraging the capacity of humans to teach concept to other humans usually. So when you want to teach something to people, you try to find ways, strategies to give examples, or to find explanation or ways to detail the problem and so on. And our idea, and that's in line with this works here. I mean, that's the work of my students like Benu, Shoteo. it's ready to do the same with machine learning techniques, okay? How we could design ways to help people to teach a concept to a machine in order for the machine to behave like the way you want. So it's the same thing that artists and that I've shown before are doing, is that they are basically teaching the machine to have a certain behavior, to reach a certain aesthetics. And here we are just formalizing it in the HCI field. Okay, I guess one important thing with this formalism, when you start to think about teaching and with this kind of interaction loop, you start to see a conversation appearing between the teacher or the maker and the material used to make, which is here the machine learning. And so I strongly believe that this approach of EML or interactive machine teaching really can go in line with what's shown called reflection in action or reflection on action, meaning that while you are basically teaching the machine, you could reflect on your own action to say, okay, I'm going to steer the model towards this behavior or not. But you can also reflect afterwards on what you have reached, what you have achieved, and try maybe to change and change the strategy. So that's really much related to this really important aspect in design. And also the fact that the fact that basically through this workflow, the fact that function reside in the expression of things. I mean, I'm just taking a quote from Alnas and Rostrom, is that you are not building your machine learning techniques such as achieving a task like what the tool could do. So the function of what you're doing is not necessarily decided before, but basically through this teaching and through the interaction process, basically the expression of the machine learning technique, so what it's going to generate or what the prediction is going to do, will also lead to a certain function of the system. And so that's something that I also relate very well to the design process and considering machine learning as the design material. And we could relate that to also form giving or material strategy. And on this, I'm going to jump to my conclusion discussion because it's 35 minutes and I think we are reaching the time. So I guess the message through the different example was that the creative and artistic context, I think, made apparent how machine learning is crafted. So I think this notion of craft with this technology is very important and overcome. While what we can see is that function of this technology as designed by tech enterprise and corporation is very coercive. You should use the technology that way, and it's where artistic practice can help us, or creative practice can help us to think in differently. And I think it's one of the very important key here ingredient is the interactivity. Interactivity enables form giving, enables conversation with the machine learning material. For instance, through exposing the learning process. So what are the research directions? There are many. I think what is important here is like what skills and tools are needed to work with this design material. This is not yet clear. I mean, I'm talking about things with projects, but I don't know in a curricula or in pedagogy, how you could teach how to work with this technology as a design material. The second question is how are machine learning and AI innovation changing design practice? Which what I've seen, I mean, you didn't see anything here about what we call today generative AI, like prompt-based generative image or sound and so on. So what does it change? I mean, you could develop a practice and then the year after you have a completely different kind of technology that would maybe change completely our practice. How could we cope with that? And finally, how can we inflect in AI design from what we learn from the creative practice? So that's, I think, also a very important question. So avoiding the coercive function of tech corporation, but more trying to inflect and influence the AI design. And on these three questions, I would like to thank you for listening. And yeah, you can reach me via email if you want. And we have 3 minutes for questions.
Yeah. Thank you very much for this fascinating talk. Any questions from the audience?
Hi, Professor. About the discussion, about if I doesn't remember how the generative AI will change the process of design. I think maybe I can have some experience that I myself doesn't good at drawing, but used to be when I use Stable Diffusion, I found that I could use some prompts or use some keywords to generate some pictures. But then I found that there are some shortcomings. That communication between the Stable Diffusion is very complex. That's for me. I actually when I talk to the Stable Diffusion, I don't know how it will output to me, and I found that the result is only good when I don't know when I don't know what the result is. Just as when I have a clear vision of what kind of picture I want, then the result would never fit my vision. And later the OpenAI they developed the DLE. I found that it's some kind of more progress than the Stable Diffusion because the ChatGPT is also good at natural language processing. So I found that it's more easier for me to develop some pictures. But then I found that when I was in a session, such as the model gives me a picture and I talk to him, change the picture like that, then it doesn't work. Then it just doesn't respond to me. So okay. So the question is that what kind of interaction you think is important, such as when we think the AI is a design material, how we could interaction with this material? What is the best way?
So you, in your question, for you the machine learning is this generative AI like DALL-E or Stable Diffusion, and I don't think there is a really simple answer to that, because otherwise, it's like there will be tools that maybe a lot of people will be. I don't think there is a simple answer to that. The thing is, what I can see, and when we could see with also colleagues and people with who we are talking, is that these are super powerful tools as long as you could express your creative ideas through words. But what happened with people that are not, so comfortable, with the expression through words and language? So I guess part of the answer is like, okay, this is like high capacity models that can generate a lot of things, but how maybe we could imagine other ways maybe to interact, other modality just to interact with this technology. I think this can be a really interesting part of it. I think language can suit a lot of things. It's a lot of use case, but it's really limiting for several artists, and it really constrained the creative process through one type of modality, which is, I think, problematic.
Yes.
Thank you for.
It's working.
De la bouche. Sur ton menton. Sur ton menton.
All right.
Voilà.
Perfect. So yeah, I saw this slide with the feedback loop, and it made me think a lot about RL and especially RLHF. Is that a fair comparison? And second thing is, in RLHF, it suffers a lot from that efficiency and needs a lot of interaction. At the beginning, you showed that like an artist had labeled 1,000 images, but I don't know how feasible that would be for like that sort of interaction loop.
I'm not sure to hear like what is the question? Sorry.
Yeah. So I guess I'm wondering about uh, the feasibility of having that RLHF like loop with like a few, like one human maybe, one user versus.
Yeah, well, I think our LHF is like it has been really instrumental to make these things work, like ChatGPT, and that's really something that learns from human feedback. That's really all the point. Okay, the thing is, the way it's implemented now. I mean, I don't know if I'm answering your question, but the way it's implemented now, it's kind of hidden the way it's using human feedback. But again, I mean, users are data provider. I mean, I guess all the point of this talk and that transfer to maybe the new generation of generative AI is like how you give agency to the user. So potential for action, how you could maybe author your own RLHF methods, and you can actually. I mean, that's technically feasible. That's my point. That's not what these companies are putting forward because it's not interested for them. But that's something that could be investigated and can be really interesting as a research project or something to
Maybe I have one last question. So you talk about in your last slide and just now about companies and their coercive vision. I want to hear maybe an elaboration of what is this coercive picture of what these companies are trying to do, and then also what do you imagine as the alternative? That's kind of like the vision of what everything that you're working on can lead to.
Yeah, I mean, I use this word a few times. I think it's, I mean, to make the parallel, I mean, what I presented here and the interviews we did with these artists that were using maybe the old version of generative AI, that was a kind of another way of, another culture, another way of partnering with companies as well. So back in the days, you have like the models, they were put on GitHub, completely open. An artist could take it, hack it, train on this data, and do artwork with it. So all the GAN stuff is made with that. And I think there was a kind of nice balance between art field ecosystem and maybe the company ecosystem. I think when we are now, it's much more coercive in a way because models are much bigger, which means that much less easy to appropriate by someone because we don't have the computational resource and the data. And what we said before is like also the input modality has been also restrained. Okay, I mean, language is, you can do a lot of things, but still it's language. It's not like abstract numbers that you can explore latent space the way you want with gestures or with even with words or whatever. And I guess since also it has been reached this scale, I think that the way it's designed is not for people to be creative. It's an enterprise, and that's something we are discussing with our colleagues. It's an enterprise where the idea is to make profit in a way. So and it becomes recreational more than everything. Meaning like how they kind of they open the potential user of their product. So I think they really design it in order to be profitable in a way by constraining few things, and one of the first thing is the type of inputs you can have. Then there is also post-process on the prompts that you can do. I mean, you can use, maybe you start to use like prompts that are really racist or xenophobic. There are things that, I mean, for the best, that are avoiding that you generate image, but in any case, there are ways that we are completely opaque to target the generation of the artifacts the way the company would like to. And there is less and less way for people and user artists to actually have an agency on these things, on the data, on the way prompts are or the way modality are used to generate image. And on the parameters that you can use to generate maybe more than one image, but maybe like 1,000 in order to So I think this is in that sense, it's kind of coercive, and in that sense, it's also normative in some sense. Then what we can do, alternative, I think it's, there are alternatives in the academic research, so maybe to go very quickly because we are over time, but I think there are, because the public research in ML also face this problem, like how they can compete with, you know, companies, big companies developing and researching ML and AI. So you can see in academia that they are also pushing ways to say, okay, let's try to build models that are using less data. Let's do as good as we can do now, state of the art, but with much less data, much less computation. So let's not try to go further and even better and better. No, we do the same, but with much less data. Let's do something decentralized, like federated learning. So we are not like really dependent on one big cluster, but let's collaboratively all compute a bit of the model and maybe gather all these things. So, and there's a lot of things happening like this, really into the participatory AI, participatory machine learning, frugal AI, working with less data, that are really interesting, and I think it's where there is many ways to do in terms of human-computer interaction with this technology. Because we are not facing this big monolithic black box, but now we could interactively interact with piece of the model, with part of the data set, author one part, collect with another part, and I mean, imagine different scenarios. I don't know if it's really clear, but there are, yeah, alternative research direction right now in AI and HCI.
That's fascinating. Thank you for this really interesting talk. And I think actually at this end of the talk, you're hitting on really fundamental notions of freedom and sharing and who owns things and who controls and whether it's open or closed. Anyway, with these thoughts, thanks again, Baptiste, for this wonderful talk.
Thank you.
And thank you for your attention.
Thank you.